we will solve this today's LeetCode problem. The question is the lucky numbers in a matrix, and this is the LeetCode easy one, right? So let's see what the question is asking. So we have given a m cross n matrix of a distinct number. Return all lucky numbers in the matrix in any order. A lucky number is an element of the matrix such that it is the minimum element in its row and maximum in its column, right? So basically, we have given a matrix, and a lucky number is an element of the matrix such that it is a minimum element in its row and maximum in its column, right? So if we see this example, the matrix one, which is given here. So this is the element which is given, first example, right? So if we see here in this row, 3 is maximum, 3 is minimum, sorry, 3 is minimum. In this, 9 is minimum. In this, 15 is minimum. And if you see column wise, if we see column wise, in this column 15 is maximum, right? In this 15 is maximum. In this 15 is maximum. So basically, okay, in this 15 is maximum, so 15 is the maximum value in this column, which is maximum. 16 is maximum, so we will put 16. In this, what is maximum? 17 is maximum, so we will put 17, right? So basically, if you see in this particular column, the minimum element is 3, but in this particular column the maximum element is not 3, right? Same goes for 9. In this, 9 is minimum, but 15 maximum is not. But if you see in this 15, in this row 15 is minimum element, but the maximum element is also 15 in this particular column. The same goes for all the elements. If you check that, this is not a minimum, this is also not a maximum, this is also not minimum, this is also not a maximum. So but if you see, this 15 is minimum in this, in his particular row, and in his particular column it is a maximum one, right? So 15, we will return the 15 as an answer, right? So basically, this is easy question. You understood that the brute force, what will be the brute force one, right? And if we see the constraints here, there's the constraints are 50, right? And can be more than 50. That's 2500, right? So if we see brute force, that you can check for each and every element moving for in row and in its column, that whether in its row it is a minimum and in its column it is a maximum, then it is a lucky number, right? So brute force would be that we can check, we can check for each element and iterate in its row and column and find that whether it is minimum in its row and maximum in its column, right? That's how. And if it is there, and if it is lucky number, and if it is lucky number, we will include in our answer, right? In our answer. So this is a brute force way, right? This is a brute force way. So for checking for each and every element in whole row and its column, one element will take uh, o of n plus o of m, right? And there are o of n into m elements, right? So o of n into m, and each element takes o of n plus o of m. So this is again o of n squared plus o of m squared, like something like that, right? So this is a very brute force approach, right? This is a very brute force approach, right? But can we simplify this, can we simplify this? So what we are doing, we are checking for each and element and moving in row and its column each and every time, right? For each and row, in each every time. So can we simply can we simply just store the max and the mean elements for columns and rows, for each columns and rows, for each column and each row separately, and check that, right? What I mean, right? Instead of iterating in the same column, in the same row again and again for each and every element, because see, for 3, 7 and 8 you will iterate this same row 3 times. For 9, 11, 13 you iterate in this row 3 times. for 3 9 15 you iterate this in this column three times, right? So you are repeating, no, you are repeating. So what we do, we will just store the we will iterate only once time, and we will just store the max and mean element for a max element for each column and mean element for each row, and store that, right? And what we will do, we will check that whether the particular for particular row and for particular column, if this element is the same. What I mean is that, suppose I have stored for 3783 value, right? This is the minimum. For 9 11 13, this is 9 is the minimum. 15 16 17 15 is the minimum. Same for 3 9 15, I will store max elements, right? For column wise I will store max element, for row wise I will store the mean elements, right? And what I will do, I will again iterate in whole, and I have stored this 3 9 15 and 15 16 17 in other places, right, in one vector or anything. And I will see that whether at this position, what is this position, 0 comma 0. So 0th value is rowth value, and this 0 is a column's value. So if this and this is same as this 3, it means this is a lucky number for sure. Same goes for other ones, right? Same goes for other ones. Like if 0 0 and 1, so 0 is row number which is 3, and 1 is column number which is 16. So this and this and this is not equal, right? So all the both are equal. So what happened, that row I is equals to, should be equals to column j, should be equals to the matrix I and j. This would be the, this should satisfy, right? This should satisfy. And what is row and column j? So row will store, row I will store the main element of a particular ith row, right? Of a particular ith row. And same for column j, that this will give this will store the max element of a particular jth, max element of a particular jth column, right? This is true. So this is how we can solve this, right? So let's just see the implementation part, how we will implement this, right? So first thing is to find the size of matrix, rows, number of rows and number of columns. So matrix dot zero dot size, right? Now, what we need to do, we need to find the row and the column j. So we will take an extra rows, and which is initialized to column, a number of rows, and the column which is initialized to number of columns. Now, what we will do, we need to store the minimum element for each row, right? So for each row is and j0 less than m j plus plus. We will just iterate in each row, right? This is to iterate in each row, and each row will be stored the minimum element. So we will take the minimum element which is initialized with enter max. Okay, and now we will store the minimum. So this will be the minimum matrix I j, right? And this is the minimum. So this will be row I, and this is minimum. This is how we solve this problem, right? For each row, I will store minimum elements by iterating in particular row, right? Same goes for the max elements. Same goes for the columns, right? We will store the column, so we will just change this j0 j less than m j plus plus. This should store the maximum elements, so we will store the maximum, and this will be minimum I0 I less than n. So we are iterating in column, right? That's why I'm changing the variables, right? We are iterating in columns, so we are iterating in columns. So this would be the max, and this would be the min, and this would be I and j similar, like. So we are iterating in columns, right? And what we will store, we will store for each column j as a max element, right? And what we need to see now, we will again iterate. So we will again iterate, it's the same thing, right? We will again iterate just to check that whether the particular element is same as the row I and row j or not, right? So what we will do, we will just we will just check that matrix I j should be equals to the row I, and the row I should be equals to the column j, right? and if it is equal, then it means we got our answer. I will store, so we have given a vector, so we will return in vector answer, and this is dot pushback the matrix I, or you can write row I, any one thing you want, because all are equal, right? And we will just return our answer at last, right? So this is how we solve this problem. Let's run this and see whether we have passed the sample case. Let's submit it. Yeah, we have passed all the test cases, right? So what the time complexity and the space complexity would be? So time complexity is, the first thing is to iterate one time, again iterate one time, again iterate one time. So this is three times we are iterating in whole matrix for storing. So that will be 3 into O of n to m, right? 3 into O of n into m. So basically it is ultimately O of n into m, right? And space complexity would be, so the first, we have taken a extra row of n size and extra column of m size, so for storing the max and the minimum element, so that would be O of n plus O of m, right? O of n plus O of m, right? This is the space and the time complexity for this problem. Okay, can we further optimize it, right? So this O of n into m into, for sure, because we need to find the lucky number, so it's for sure that we need to iterate in matrix, right? So this cannot be reduced, right? Can we reduce this space complexity? Can we do it in O of 1 or something? So if you see here one thing, we have given a distinct numbers, right? We have given a distinct numbers. We have given a distinct numbers. It means that any element in the matrix is not repeated, right? Any elements in the number is not repeated. So if we see one thing, that suppose uh, this is given a b c d e for this r1 row, and p q r s t r2 row, same goes for anything else at m, and nothing, anything you want, right? uh, like q, not q, because we need distinct number, right? A b c, right? A b c d and e in capital letters, right? These all are distinct numbers, right? Given we have, right? Also for, so I'm claiming that there will be only one lucky number if this is a distinct numbers we have given. Why? the first the first thing I got this, that the answer is already only one answer, right? We are getting only one answer. So I thought of that, how will this is only one, right? So think like that, that suppose s is a lucky number, right? Suppose, let s is a lucky number, right? So if s is a lucky number, it means in r2, in r2 it is the minimum, right? S will be the minimum, s must be minimum, right? And in, okay, let's give the column number also. This is c1, this is c1, this is c2, uh, 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 right? This is c1, this is c2, this is c3, this is c4, and yeah, this is c5, right? This is like that, right? This is c5. Let's write this, it's over, right? Right. So basically, what is given, this is c1, c2, c3, c and 4. Let's give it spaces, right? Let's give it spaces, some spaces only. Fine, fine, right? Okay, good to go. So if you see, if s is minimum, s is lucky number, s must be minimum r2, and s is must be maximum in c4, right? In c4, s is must be max. And suppose if I'm taking that, uh, there will be more than a number which is more than one lucky number, right? So suppose I am taking a as a lucky number, right? I'm also taking, let's take a is also a lucky number. Let's take a is also a lucky number. So if a is also a lucky number, it means in r3 a is must be minimum. A is must be minimum in R3, and in C1 A must be max, right? In this A, in this column APA, if A is a maximum number, it means this P A all are all are minimum, right? All are minimum from it. If A is greater than in its column, then P is also greater small than this P. And we know that in this, for this row, S is minimum, and we know that for this row S is minimum. So P is greater than S, right? P is greater than S. But one thing is also sure, that in this row, if A is a lucky number, then A is less than D. A is less than D. So A is less than D. D is greater than A. But in this column, in particular column, S is maximum where D is lying. So S is greater than D, right? So don't you think this is something like A is D is greater than A, S is greater than D, but see, A is greater than P and P is greater than S. So A must be, if we see this particular two, so A must be greater than this S, right? A must be greater than S. And if we see this, D is greater than A and S greater than D, it means S should be greater than A. So this is contradictory, right? This is contradictory. This is contradiction, right? Contradiction. This is contradiction, right? Because I have assumed that we have S as a lucky number, and also I have assumed that I have more than one lucky number, and I suppose that A is lucky number for me, right? But if I suppose A is lucky number, but I'm not getting, I'm getting the wrong way, right? I'm getting the wrong way, which is a contradiction. It means my claim, which I have told, that there there can be more than one lucky number, is wrong. More than one lucky number is wrong. So this is how we find that we only can have one lucky number in whole matrix if number is distinct, right? If number is distinct, right? If there is no, is not distinct, so we can have more than one lucky number. But if number is distinct, we can only have one. We can. It means the conclusion is that we can have only one lucky number in whole matrix, right? Okay, the one thing is sure that we have one lucky number, but how we will find it? So if you see that we need to find the minimum in row but maximum in column, right? Minimum in row and the maximum in column. So what we'll do, we will find minimum in rows and take all the take the max value, take the max value among the minimum value of each row, right? Also we need to find the max value in particular column, but it should be minimum in its row. So what we'll do, we will find max in columns and and take the min value among the max value of each column. And if it is equals, and if both are the same value, it means that is a lucky number, right? And how I'm deducing it? Because we need to find the minimum in row, but it should be maximum in but it should be also maximum in particular column. So we need to find the minimum in all the rows and take the max value among them. So that would, and for verifying it, we take opposite of that, we will take max in columns and take the minimum value. If it is both of the same, then we will definitely know that this is a lucky number, because I am ultimately knowing that we can have only one lucky number, right? We can only have lucky number, and it should be the min in rows and the max in columns. So let's verify it by taking an example which I have told you, right? So let's take this as an example, right? Let's take this as an example. So if you see what I have told you, that I will take the minimum. So within this, one is minimum, in this, three is minimum, and in this, 12 is minimum, right? And what I will do, I will take the max of both of them. Why I need to take a max? Because in columns it should be max, and we this is 1 3 12 for each particular row. So for particular row, and we need maximum value. So the max value would be 12 among 1 3 and 12. The max value is 12, right? Okay, now for column I need to find the mean value, max value. For 1 and 15, max value is 15. 10 3 16, it would be 16. and and 4 8 17, it would be 17. And 2 7 12, it would be 12. And we need to find the min between them, and between them is minimum is of course 12, which is 15, 16, 17, and 12. So answer is 12, and see, both is equal. It means 12 must be 12 is a lucky number, right? So how we will deduce the lucky, that there will be only one number, one lucky number. And the one lucky number, how we will find? So first thing need to find that we need to find each row minimum elements, and we need to take a max of them. So for verifying that this is a maximum, we do the opposite thing, that we will take a max in all columns, and we will we will extract the minimum elements. And if both are equal, I'm sure about that this number is lucky number. We got our answer according to this, but we need to verify now, because there can be possibility that there is no lucky number, right? So yeah, this is how we will solve this problem. So basically what we do, we will just take, instead of this instead of this row number, we will just take a row that will store the that will store the min max number, right? So let's take as a x, right? This is like, let's take as a x, and which will have main value, because we need maximum value. This will be the same, that we need to store the main value for each rows. And for after this, instead of storing this, I will just take the max of this minimum elements for which we find for each rows, right? Now the same thing for goes for this here, that I will take the end max value, right? I will take the minimum value for that, for each column. And we need to find for each column maximum values. And for after calculating for each column, what we need to do, we need to take the minimum of them. So that's what we do, we take the minimum of them. That's why we initialize with enter max. And after that, instead of just checking for each and every element, we will just check that whether this, if x equals to y, if x is equals to y, it means we got our answer. Otherwise this would be empty, right? So we don't need to take any rows and extra rows. If this is equal, it means we got our lucky number. Otherwise we will return an empty, because there will be only, okay, we all one thing's for sure, that we need to return in vector form, right? So we need to typecast this, so we will return in like this x, right? So this is how we solve this problem, right? Let's run this and verify this whether we are correct or not. Yeah, we are correct. Let's submit it. Yeah, we passed all the test cases. So what we have done, we have the space complexity as O of n in 2m for sure, because we are finding the elements mean and max. So O of n in 2m for sure. And the space complexity is reduced from O of n plus m to O of 1, because we have taken only variables. So hope you liked it and understood it. Thank you so much. Bye bye.